Okay. Today we're going to start talking about solving trig equations. Okay. And you're going to need your unit circle out. So, because we're going to be looking at it a lot today.
I'm tired of the stupid unit circle. Stupid. I don't even think I have to take calculus in college. I think I just have to take like college algebra, and that's it. And then like some physics math.
Okay. Here's a graph of the cosine function. And we have this equation, cosine of x equals 1/2. So this x represents an angle, and we're going to be using radian measures. So we want to find this angle measure. Okay. What angle does cosine equal 1/2? Well, if you look at this graph and you look at one period of the cosine function, which is from 0 to 2 pi, from here to here, and then it just starts repeating, correct? You can see that cosine equals 1/2 at pi over 3 and at 5 pi over 3. Okay? And then equations of trig functions are a little bit different because it's a periodic function where it repeats. So if you're asked to just solve an equation, unless it tells you a certain interval, you have to assume that the interval is from negative infinity to positive infinity. Okay? So that means, okay, when we start over here, okay, here's another 1/2, 1/2. So it's just we're going to have lots of places where cosine equals 1/2. But if you look at this, your unit circle, remember, cosine is the x value, sine is the y. So find where cosine is 1/2 in all the any place all the way around the circle. So right here at pi over 3, which is what the graph showed, and then again right here at 5 pi over 3, which is what the graph showed. But if we go around the circle more than one time, because we can go around it many times, that's what the graph is. If it just keeps going and going, it's like going around the circle over and over. So at pi over 3, if we go around the circle again, then we're going to be having sine is 1/2, cosine is 1/2 again. And if we go around again, so every time you make a revolution, that's 2 pi, and your cosine will be 1/2. And the same with 5 pi over 3. So when you solve a trig equation and you have to find negative infinity to positive infinity, you can't just say pi over 3 to 5 and 5 pi over 3. You have to also add every revolution. So n represents one time around the circle. So you would multiply however many times around the circle times 2 pi. And that would be another place where cosine is equal to 1/2. Okay? So your answers are going to look like this if you're finding cosine from negative infinity to positive infinity. Now, sometimes you're going to see this here in a little bit. You'll be asked to just find it from 0 to 2 pi. Well, if that's the case, you would just have two answers, pi over 3 and 5 pi over 3. Okay? So it just depends on what interval. And you need to specify the n is an integer. And normally we do that. You put n is an element of z. And z is integers. Okay, so that's a way to put that mathematically. All right, now before we move on, we need to talk about what the period is of each of our functions. The period for sine is 2 pi. It's one full revolution around the circle. Now you remember what period is, right? It's how far the graph goes and then repeats itself. Okay, so one period is for sine is one time around the circle, then it repeats itself. Now, your period for cosine is 2 pi. But your period for tangent is just pi. So after you go halfway around the circle, tangent repeats itself. Tangent is sine over cosine. So you could set and do x over y, y over x, and you could see that it starts repeating itself again after pi. So when you're doing tangent, you only have to check from 0 to pi, not the whole circle. Okay? And that works for cosecant. Cosecant and sine are reciprocal, so they'll have the same period. Cosine and secant are reciprocal, so they'll have the same period, and then tangent and cotangent. Okay, we'll have a period of pi. All right, so let's look at example 1. Solve by isolating trig expressions. So example 1a, and we're going to solve. And it doesn't say our directions are just solve. It doesn't give an interval, so we just assume it's going to be from negative infinity to positive infinity. So we have solve 2 tangent x minus the square root of 3 equals tangent x. Well, first thing we want to do is we want to put our tangent x's together. Okay, so we've got 2 over here and 1 over here. So the easiest thing to do would be to subtract tangent x from both sides. So 2 tangent x minus 1 tangent x would be how many tangent x's? 1. It'd be like 2x minus 1x. It's just 1x. So 2 tangent x minus 1 tangent x, just tangent x. Now these two cancel each other out. So we have tangent x minus the square root of 3 equals 0. Now we want to find tangent x. So just like you would if you were solving for x or y or whatever, you want to isolate it. Okay? So we want to add square root of 3 to both sides. So we have tangent x equals the square root of 3. Now, what is our period of tangent? Pi. Okay? So we want to check 0 to pi. Okay? That's what we want to check. We want to check this interval, and then we'll have to add pi in to each one of them, okay? So what you want to do now is you're going to use your unit circle to find out when tangent is equal to the square root of 3. Now, tangent is sine over cosine. Sine is your y, so tangent is equal to sine over cosine. Sine is your y, cosine is your x. So, look at your points right here and figure out when you would do y over x, you would get square root of 3. If you need to write it down, you can. Is it going to happen here? No, because the square root of 2 over 2 divided by the square root of 2 over 2 is 1. So it's not going to be here. So it's got to be here or here, because it's not going to be here or here. So if we do 1/2 divided by the square root of 3 over 2, will we get square root of 3? One half divided by the square root of 3 over 2. 1/2 times 2 over square root of 3, right. So we would get 1 over the square root of 3, wouldn't we? Not square root of 3. So,
Actually, square root of 3 over 3.
Huh?
It'd actually be square root of 3 over 3.
Exactly. So, let's try this one then. Square root of 3 over 2 divided by 1/2. That would be square root of 3 over 2 times 2, right?
Mm-hmm.
Okay. So we're going to be looking at the ones that have 1/2 as the x and square root of 3 over 2 as the y. Now we're only checking 0 to pi. Okay? So right here's one of them. It's not square root. Pi over 3 is one of your x values. Now, if we go on around, here we have negative 1/2 and square root of 3 over 2. But if you divide that, what would you get? Would you get positive square root of 3? No, you would get negative. So we're only concerned about the positive. So from 0 to pi, that's it. So that means that our answer is pi over 3. And on these, we're doing negative infinity to positive infinity. So we wouldn't add 2 pi in, we would just add pi in. Or n pi, however you want to say it. So what that means is, we're right here. Tangent is square root of 3. So that means if we go halfway around the circle to right here, we would get tangent is square root of 3. And that makes sense because you do square root of 3 over 2 over 1/2, and they're both negative, so you get a positive. And if you go halfway around the circle again, you'll be back where you started. So every time you go halfway around the circle, your tangent is square root of 3. Does that make sense?
Yeah.
So when you put plus pi in, the n is the number of half revolutions, half circles, okay? All right. Example 1b.
Any motion? Do example 1B on the front page.
Huh? What'd you say?
Example 1B on the front page.
We're going to do 1c. It'll be, wait. Do I have a 1c? I may be getting mixed up with algebra 2. No, we're only going to have 2 examples on here. All right.
The other x?
Huh?
Plus the square root of n?
Plus pi n. That's what I was saying. Pi n would be halfway around the circle. All right. So, we have 4 sine x equals 2 sine x plus the square root of 2. And we're solving for negative, the whole forever. Negative infinity to positive infinity, which means we'll have to have one of these on our answers. Except for this one is our period pi or 2 pi. For sine is our period pi or 2 pi. 2 pi. So when we check, we're going to have to check 0 to 2 pi. We'll have to check all the way around the circle. But first, we've got to get what sine x equals. So what do y'all think we're going to do first, based on what we did earlier? We want to get our sine x's together, so we have 4 sine x's over here and 2 sine x's over here. Huh? We wouldn't divide, we would subtract. Yeah, we'd subtract 2, because it's not sine x times the square root of 2. If it was times, yeah. So we have 2 sine x equals the square root of 2. Now what would you do just to get sine x?
Subtract sine, no.
We got 2 times sine x.
Divide by 2.
There you go. It'd be like if we had 2x, you'd divide by 2. So sine x equals the square root of 2 over 2.
That'd be like 45 degrees.
Okay?
And 225 degrees.
All right. Sine is our y value, right? So we got to look at the whole unit circle and find where y is square root of 2 over 2. Right there. Pi over 4.
Mm-hmm. And our 5 pi over 4.
What about 3 pi over 4?
Yeah.
3 pi over 4 is positive. Now down here, 5 pi over 4, it's negative, so it wouldn't be that one. And over here at 7 pi over 4, it's your y is negative. So x equals, what do we say, pi over 4. And what?
3 pi over 4.
Yeah, that's right. Now, since we're going from negative infinity to positive infinity, we've got to add plus 2 pi n, or 2n pi, however you want to put it. So this means n represents your number of times around the circle. So if you went 3 times around the circle, then you would be 3 full revolutions from pi over 4. Your sign would still be square root of 2 over 2. I need to put check 0 to 2 pi. This is what we're solving for. Okay? Okay, example 2. Now, example 2, we're still solving. It's just going to be a little bit different strategy to solve. So, example 2a, we're going to have 2a and 2b. Solve 4 sine squared x plus 1 equals 4. So, if it doesn't give you an interval, then you assume that you're solving for negative infinity to positive infinity.
Subtract 1.
But, wait just a minute. But when we get our answer in a minute, we're going to check 0 to 2 pi. Good, that's right. Subtract 1 from both sides. So we have 4 sine squared x equals 3.
Divide by 4.
Divide by 4. So sine squared x equals 3/4. Now how do I get sine x?
Square root. It would just be the square root of 3 over 4 because you keep 3's.
Well, you take the square root of 3, which is square root of 3, over the square root of 4, which is square root of 4, 2. So don't forget it's going to be plus or minus. Okay, when you use the square root property, it's plus or minus the square root of 3 over 2. So this time we're going to be looking for positive and negative square root of 3 over 2 for sine. So go to your unit circle. Go ahead and write x equals. We're going to check all the way around the circle for when the y value is square root of 3 over 2 or negative square root of 3 over 2.
Pi over 3.
Pi over 3.
2 pi over 3.
Yep.
Negative, it can be negative 2.
Yes.
7 pi over 6.
7 pi over 6. No, we're looking at the y value.
Oh.
That's it. That's the x.
4 pi over 3.
4 pi over 3, and there's one more in the fourth quadrant.
5
pi over 3. So x equals, and I'm just to save space, I'm going to do it this way. I'm going to cheat a little bit. Still writing each one of them separately. We're going to put pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3, and then since we're doing negative infinity to positive infinity, we would have to do multiples of the period, which would be 2 pi. And technically, you're really supposed to put this, letting whoever might be looking at this know that we're talking about integer multiples of pi, 2 pi. I mean. But if you leave that off, I probably won't even count off. Okay, good. Example 2b. Solve. 3 cotangent squared x plus 4 equals 7.
Minus 4. 3/3 is 1.
Mm-hmm.
Square root of 1 is 1, so cotangent x equals plus or minus 1.
If you take the square root of both sides, you're right. Cotangent x equals plus or minus 1.
Like this stuff, more algebra. This is kind of like more algebra.
Algebra.
And yeah, I like it a lot better. I can do it just.
All right, now, what is cotangent? What are we going to be looking for? What are we going to be looking for on this thing? Well, tangent was sine over cosine, right? So what's cotangent? Cosine over sine?
Yeah.
Cosine is your x, sine is your y. So you're looking for x divided by y is 1 or negative 1. So when is x divided by y going to be 1 or negative 1? It's not going to happen here, is it? You'd either get 0 or undefined on these. Well, I think of them as 4 corners, even though they're not corners. So look at these. When would you get 1? Well, in this quadrant, when would you get 1 if you divided x by y?
Not in pi over 3.
We already.
Pi over 4 probably.
All right, well, what is the square root of 2 divided by the square root of 2? I mean, what's the square root of 2 over 2 divided by the square root of 2 over 2? 1. So there we go. All right, what about over here? What would we get?
Negative 1.
Negative 1. Are we looking at negatives too?
Yeah.
Yeah. So what about here? Positive 1, right?
Mm-hmm.
Negative 1. So all 4 of those. So x equals, and we'll do like we did a while ago, since I'm running out of room. Pi over 4. What else? Go around the circle.
3 pi over 4.
3 pi over 4.
5 pi over 4. 7 pi over 4.
Plus what?
2 pi n.
This is cotangent. Tangent and cotangent only have a period of pi.
So why do we go all the way around? Why do we go all the way to the bottom? Then we couldn't list the ones at the bottom.
You know what? You're exactly right. And I want you to look at my notes. I was not paying attention. See, I didn't write up here that we needed to check 0 to pi. And look at my notes from when I did it myself at home. What do you see?
Scribble them out.
I did the same thing, and then I realized what you just realized. So actually, these 2 we don't need. Well, I guess it doesn't hurt to put them, but it's just, there's no use in it because you only need to check 0 to pi. So you got to be careful. As you can see, I was not careful.
We'll just go ahead and skip the back part.
No, we're not skipping the back end part. Okay. Now, on this one, the directions are find solutions on the interval 0 to 2 pi. So now on this one, if you were doing tangent, since you're not doing the pi n, since you're doing cotangent, you would list all 4 of them. Because you're only doing that one, so you see what I'm saying? Because if you're not going to put plus pi n, then you've got to list all of them that's in the whole circle. So that, be careful about that too. All right. So example 3a. Cosine x sine x equals 3 cosine x. So basically, if you're checking the interval 0 to 2 pi, you got to check everything, even if it's tangent and cotangent. Okay. There's really not a whole lot you can do here. And I'm surprised that yesterday somebody didn't say, well, let's just divide both sides by cosine. Well, what would happen? The cosine would disappear. You'd get 1 and 1. And that's not going to work. So you can't do that.
If you divide both sides by cosine, you'd get
sine x equals 3.
You get tangent equals to cosine. Yeah.
No, your cosines would just cancel out. So you'd have sine x equals 3. And you don't want to do that.
Well, you divide cosine. Oh, yeah.
Okay. All right. So what we want to do is, let's set it equal to 0. Let's move this over here. So we have cosine x sine x minus 3 cosine x equals 0. So now we can factor out a cosine x. So what would we have left in this term?
Sine x.
Sine x.
Minus 2.
Minus what?
3.
Okay. Minus 3 equals 0. All right, so now what you do is you just set each one of these equal to 0 and solve. Because if cosine x was 0, it'd make the whole thing 0. If sine x minus 3 was 0, it would make the whole thing 0. So just like when you factored, and you got like x plus 2, x plus 4, and you set them equal to 0 and solve for each one, that's kind of the same idea. So we got cosine x equals 0. So when is cosine equal to 0? And we're going all the way around the circle. Cosine is which value, x or y? Oh, be sure and write this at the top of your unit circle. X. So when is x 0? Pi over 2 and 3 pi over 2. Very good. So x equals pi over 2 and 3 pi over 2. And that's it. You don't put plus the 2 pi in because all we wanted was from 0 to 2 pi. We're only concerned with that one interval. Now we set the next one equal to 0. Sine x minus 3 equals 0. Add 3 to both sides, so sine x equals 3. So x equals, so when is sine 3? Sine is your y value. When is it 3? Think about the graph of the sine function. Remember, its maximum is 1, its minimum is -1. So it oscillates between 1 and -1. So when would sine ever be 3? The answer is never, okay? Sine x will not equal 3 because it only goes as high as 1 and as low as -1. It oscillates between the two, okay? So this is your answer. Example 3B. Cosine to the 4th x plus cosine squared x minus 2 equals 0. Now this one's a little bit different. Okay, let's say we had, I'm not sure this is going to work, x to the 4th plus x squared minus 2. We could factor that, couldn't we? Like a quadratic. Can we do this? X squared, two numbers that multiply to get -2 and add to get 1 would be +2 and -1. Couldn't we do that? Same idea right here, except instead of x to the 4th, it's cosine to the 4th. Instead of x squared, it's cosine squared. So we're going to factor this one just like we would a quadratic, our product and sum method. So we'd have cosine squared x here, cosine squared x here. Two numbers that multiply to get -2 and add to get 1 would be +2 minus 1. Now set each one of these equal to 0. So we've got cosine squared x plus 2 equals 0.
Cosine x, cosine squared x equals -2.
So then you'd have to take the square root of both sides. And what happens when you take the square root of -2?
-2 will make it positive. No?
Actually, what happens when you take the square root of negative? Can you take the square root of negative? Not in the real number system.
So
You could with eyes,
so
but
it's
we're not
I.
doing it. No, we're not. This is only real numbers. We're not doing any imaginary stuff here. Okay? So basically, nothing. Now, cosine squared x minus 1 equals 0.
Cosine squared equals 1, so square root of 1 is 1.
Plus or minus 1.
Yeah.
Take the square root. So we want to know when cosine equals positive or -1. Now go back again. Which of your points is it x or y that's cosine?
9, 0.
Is it x or y that's cosine? X. And how I remember that is it's opposite what you'd think. I mean, I would think sine would be first, but it's not. All right, so we got to find when x is 1 or -1. Well, it's 0 is when we start. Notice this right here. This means including 0, but not including 2 pi. Because 0 and 2 pi are at the same spot. So we start at 0. So here cosine is 1. And if we go over here, it's -1. And that's it. So x equals, what was it? 0 and pi.
Such time I put up today.
What is this? Did I do the wrong one? Oh, we have a 3C. But we'll stop right there because we're not going to have time to finish it. So that will conclude part 1.